Well, we're going to get into a couple of things tonight. Usually these things sometimes last a couple of hours, but we don't have that time. But I'll get through this pretty quickly and show you a couple of things. First of all, I always like to show where I came from. This is when I started my ham radio career, and I was 15 years old and got a technician license. I was a technician for 17 years. And you're going to say, what? Because 6 meters was open 24/7. It was an amazing time. Sunspot cycles have never been anywhere close to that. I didn't know that as a kid just getting into it. I figured, well, it's going to be like this all the time. No, it wasn't. That station's very interesting. It's in Harvey Wells. TBS 50D, believe it or not, works at 75 meters to 2 meters, all tubes, and then SX99. And that big box is a converter, 2 meters, and 220. But I still have the Harvey Wells. Oh, you're probably going to not. There it is, right down over that computer. I still have it. I use it in the morning. I'm on the air every morning at 9 o'clock on AM nets. But the station grew quickly, and of course, Gonsets were king. I was one of the first 10 people to ever build a 6 meter single sideband rig. It wasn't even happening on the low frequencies yet, but a guy I met on the air, he was a chief engineer at CBS here in St. Louis at KMOX. He helped me do that. And so it just went crazy. We were taking old BC 459s and a lot of surplus gear in those days, and made a VFO out of that. Some made transmitters out of it, but it carried on, and I really got involved in building and stuff. But I loved antennas, and we're going to get into a lot of antenna stuff tonight. I got a call from Bob Drake of the Drake Company shortly after I had built that Thunderbolt. He said, you're the guy that's got a kilowatt on 6 meter sideband. And I said, yes, sir. He said, well, we have checked with the league and we understand you're just one of a few that have done this. We want you to come to our club meeting and tell us how you did it. We have a technical club. It only meets once a year. So bring us pictures and diagrams and tell us how you did it. Well, I'm just a 19-year-old kid at the time, and they wanted me to talk about that. You can see the central electronics up my head, but that was a 6 and 2 Thunderbolt I built as a kid. But we flew to the Biltmore Hotel. One of my friends had a Bonanza airplane, and I worked him on 2 meters all the time locally. And that was an amazing time. They had taken all the furniture out of one of the floors for this meeting. They had the Collins room. They had the Mosley room, Bill Halligan with Hallicrafters, and the guy on the upper left is Wes Shum. Wes Shum was the guy that brought single sideband to ham radio in 1948. A lot of people would think it would be Art Collins. No, he was 6 years late to the party and actually did it with one of Wes Shum's transmitters. But while I was there, the J-Beam company was there from England. They were looking for somebody to do a test for one of their antennas and asked me after my presentation, and heard that I had a kilowatt and a half on 2 meter sideband. And they sent their antenna over, and their antenna was 128 elements on 2 meters. It was an amazing antenna. Had a local dealer, he was a Motorola dealer, and K9SGD, and K9EBA was a contractor. So he had all of the equipment, and they put this tower up, and all of the phasing harnesses and things. I learned a lot from that. They also had put up a 110-foot Roan for me a year earlier, with a 36-foot long Telerex spiral array on it for 6 meters, and those are J-beams above it. So I really got into antennas, and this was something very special. But I doing all this kind of stuff, a small town, only 2,000 people. Guys were finding out there was a guy with a soldering iron. They started bringing me their amplifiers and stuff. and that's how I got into the rock and roll market. But in 1959, I also got a job at a restaurant. I built a pipe organ in a restaurant here in St. Louis. It was in a four-star restaurant, and I had gotten a couple of speakers from the Fox Theater that they were going to throw out because I was the organist at the Fox when I was 15 years old. It was really the step forward in my career. That same year, I became a ham, of course, but uh, I, uh, I knew what I was going to do. But in all of that, we were building a lot of equipment. I had 35 people working for me, and we were building all kinds of mixers and amplifiers and different sound systems for all kinds of people. One of the most historic was the Grateful Dead's tour. They came through St. Louis and didn't have a PA, and I did, and the rest is history. And you can go to Google and put in there the night rock and roll sound was born. And it's quite a story about the whole details of how that happened. Jerry Garcia and I became very good friends. That article was printed in Billboard magazine, and we were doing a lot of things just locally. But my first major job was with Jimi Hendrix. Hardly knew who the guy was. And the next one was Joe Walsh. And of course, Joe and I have been friends all these many, many years. But we did so many bands, and I could come back some night if you'd like to hear the stories of living with the Who or living with the Dead. I was with the Who for 6 years, and I invented the talk box for Peter Frampton and Joe Walsh, and that's another side of my history. But all of that goes down, and here's the last one. I mean, there's so much to talk about here, hours and hours. You could get into all of that. It's kind of interesting. I'll come back sometime, Aaron, and we'll do that. That group, their manager called me, said, "You the guy that's got that big PA I'm reading about?" I said, "Yes, sir." He said, "Well, I got this band. I'm taking over the management. They're just starting and they're really loud. You think you can help them?" "Yeah." "Who do you think that is?" Nobody ever guesses it. That's ZZ Top on their first job without beards. Took a few years to grow. We're still very good friends, and I do all their microphones today and stuff, and still good friends with Pete Townsend and so on. But we had all these people building amplifiers and speakers and all kinds of various things. But along about that time, I got involved in doing rock festivals, and I said, I didn't like that at all because they'd hire us to, that was supposed to have 20,000 people. It ended up having 200,000 people. And oh, we did the job okay, but it was really terrible with all of this stuff that went on. I saw too much of this, I got to tell you, because you're looking at a guy. I've never tasted beer. I've never smoked anything. Never, of course, touched any drugs. So this was all foreign to me, but that's okay. Let them have their way, and they respected me. Pete Townsend always said, "Hey, leave the guy alone. He's got a soldering iron. He makes us sound good." And we were just doing almost every one of the top groups because we were the ultimate sound reinforcement company. Again, all of it was because of ham radio. I'd get so many people. We'd go into these big arenas, especially the audio guys and electricians. "Where'd you go to college? Where'd you learn all that?" "Ham radio." "No, man, where'd you get ham radio?" And it's very, very true. It's how I learned to build things and do things from almost the first week that I had a license. And so it's been a lot of fun. I wrote the book because a lot of these guys were asking questions and it wasn't out there. There was nowhere to go. Yeah, you want to enroll in a 4-year course to do I don't know what. That book, I was very proud of it. It helped so many. And even today, I'll see guys in some of the shows that still carry it because there's a lot of things in it that are pertinent even today. And of course, Joe and I have been all through the years, have been great friends. But one day, Paul Klipsch called me. I'm going, "What?" Phone rang. I picked it up. "That you, Heil?" I said, "Yes, sir." There's a clips here, and I'm going, oh my gosh, this is God on the other side of this phone. I couldn't believe he was calling me. I want to come and see that big sound system. What is it? I said, well, around 8,000 watts. Oh, so he flew his airplane up to Marissa, Illinois, and it absolutely changed my life because he was so gracious and all that day walking through the plant. Well, why did you do that? Well, how come you do this? Where'd you learn to do that? And then I'd tell him ham radio. No, I mean, what college courses did you take? Electrical engineering? No, 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 ham radio. And the pipe organ, because I learned to listen. We had to voice and tune about 3,500 pipes. That organ hadn't been played in 20 years. And so Stan Can was the organist there, and he got me to help him substitute play, of course, and I was 15 years old. But it wasn't just the playing, it was all of the things we had to do to the pipes, 3,500 of them from 1 inch to 32 foot, and they hadn't been touched, and so we had to voice and tune. And that's where little Bobby Heil learned to listen. And a lot of people don't listen, they just hear. Hearing is a physical process. Listening is a mental process. You really have to dive and see what's going on and listen, all the little nuances and the harmonics and the distortions. And that really taught me a lot. So that was a big deal. And Paul Klipsch understood that because he also knew a lot about pipe organs. Anything that was high fidelity and very clean and clear. Well, he put me in his plane and we go down to Hope, Arkansas that night. And that's his lab. That's an old telephone exchange building. On the left, a picture of one of his K horns, a coroner horn that he did it in plexiglass so you could see it. Amazing times because the hi-fi was just starting to come in, and he was one of the father of hi-fi movement in the 50s. But he guided me to things, so many things. A couple of days I was with him. One of the things that he told me that I needed to really study on, and I had to go to the library, you guys can go to Google, is the studies of the Bell Labs. You see, when they put the telephone system together, it didn't work very well. They had two wires. They started in New Jersey, and all across America, every 500 miles, they would put up a relay station. And their thought was, we want to make sure that everything is equal when it comes to the West Coast. What we put in, we want to get out. Well, not so fast. And again, hearing is a physical process, but listening is a mental process, and they couldn't figure it out. They just listened and it wasn't good. And here's what we're talking about. I can't do a better demonstration than this. This is what the telephone system sounded like when they first turned it on. It had lost all of its articulation. There was just nothing happening. It lost its life. The essence of sound was gone. The difference of an F and an S didn't happen. So they had to figure out what went wrong. And so they put the scientist on it, the scientist of the labs. And there were 4,000 of them. They had a big job because the world was waiting for the telephone system and it didn't work. Now what are you going to do? The two leading scientists, and boy, I should hope that you guys know about these two guys, Harvey Fletcher and Dr. Weldon Munson. They came up with what they call the Fletcher-Munson curve, and it guides everything in audio But when you get down to where you're listening, probably in that room tonight, hmm, you lose a lot of things. It looks like a ride at Disneyland. And what these two guys came up with was monumental. First of all, the system, the telephone system, is only 300 to 3,000 wide. Sound remotely like something you have in your radio station? Hmm? That's about the bandwidth of ham radio transmitters. And they had the same problem that I hear almost every day. What is that problem? Well, they discovered that the human being, after studying their wonderful Fletcher Munson curve, getting together with those 4,000 scientists, they came up with this. This is maximum speech articulation, the audible frequencies that we must have to get articulation. And that happens between 2 and 3K. 2.5 is the sweet spot. And I'm going to do this again. I have a parametric equalizer on my mixer. I'm only turning one control, 2.5K. I'm able to just notch that out. And so here it goes. And so there is no EQ. You like that? You're probably having a difficult time understanding each word. The F and the S, the P and the B, the essence of sound is simply not there. It should be stunning, but it's not. I'm only going to do that again. In the reverse, here comes 2.5K. As I rotate it up, there's 800, there's 1200. And the minute I hit 2.5, you'll know it because it's right in your face. The F and the S, very distinguishable. It's very important that in any kind of speech articulation, that is applied. And we're talking about ham radio, telephones, and everything you have from your iPhone, your car radio, your television, everything that has audio. The engineers, of course, they did in their studies in their college wake up pile. Everything is taught about speech articulation for maximum voice understanding, because without it, you just heard twice. So that was really something. But okay, now that they did find this out, what are they going to do? This is 1920. There was no equalization, never even talked about. It was maybe in the English language, but it was never applied much. So what are they going to do? They did it with high pass and low pass filters, just a few resistors and capacitors. That's how simple it is. Of course, you have to know there's all the equations if you want to really figure it out. I do it a little different. I just get a whole box of capacitors and a whole box of resistors and a bunch of clip leads. And when it starts sounding good to me, there it is. I know. I'm lazy, but I'm not good at math. I don't need that. I'll figure it out, believe me. So they put a high pass filter in there. What that means, it passes the highs. All the audio, full range, goes into the capacitor. If you want to roll off lows, which is what they wanted to do, you put a certain amount of resistance to ground. Bingo, you end up with nice articulation. You want to do the reverse, there you are, it goes into that resistor, and the highs go to ground. Very simple, high pass, low pass filter. Well, there was a young kid, look how young he was, 1920s, in the late 20s. He had a job at RCA, and his job was to do something about the motion picture playback systems. Whoa. How's that going to happen? Huh? Situation there was the talkies were coming in, and RCA had the contract with many of the theaters, the big ones. And what are they going to do? John figured it out. He studied all of that that we just went through with the scientists. So he did a little thing, something like this, different high pass and different low pass filters. And in on the right side went all of the program. And then by switching those around, the output of that went to the audio amp of the screen. Bingo, you could figure out what you wanted, and then he could solder it in. But you see, equalization was not talked about. It was not talked about. It wasn't in the language until then, and nothing much happened. Think about this, from 1930 to 1967, equalization was foreign. Oh, there was a little rise when the hi-fi movement came in about 1950, but that was minor. It was just a high-pass filter, and they had like the resistor was variable. That what I know. I really got involved in hi-fi. I was only like 17 years old, and I really got involved in all that because I was wanting to play all these big round records, those big things that have a hole in them, because I had a bunch of them with my theater organ guys, and so I was involved in that, but nothing really seriously happened until 1967. Now think about this, all those decades, something so important. In 1967, a company by the name of Longevin, they were building recording studio gear, all kinds of small mixers and compressors, limiters, all that stuff. Well, in 1967, the floodgates happened. They built the very first equalizer for professional use. This was a huge step forward for all of us in the sound reinforcement business, in the recording industry. Wow. Because up until then, we didn't have much. Well, I showed you that a picture of Jimi Hendrix. In those days, we didn't have much gear. I used Macintosh amps. They were very expensive, but they were very good. And in fact, Garcia, he really freaked out when I talked to him on the phone for the first time. He asked me what kind of amplifiers, and I told him Macintosh. You got Macintosh amp? Because they were pretty expensive and nobody was using them, but I didn't know. I wanted the best thing I could get, and I did. But the mixer was silly. That little green one you see down there, that's a little mixer for radio stations or little PA systems. It didn't have any kind of equalization, of course. Now, this is 1970, we were using these things. And so what are we going to do? When equalization hit, I'm going, yeah, I need to look at that. So I didn't go right away, but the next year I went out to Longevin because I heard they were building a mixer. They had just come out with this. What a miracle. It was 8 channels, slide control, so you could easily mix rotary knobs. It's hard to see what each one is doing. This was a monumental step forward. Well, I bought 2 of them, and I built a mixer for our sound systems, had a carpenter build that cabinet for it, and there were 2 of them. I bought a pair of them. That was 16 channels. That was incredible. And up above it, you'll see there are 2 meters. That was a compressor and limiter. But then over there, it just so happened when this picture was taken, that bright light that shined from the flash, talk about a miracle, that they did the first one in 67, but look what they did in 1968. Oh my gosh. Talk about turn the audio business on its ear. We now had equalization, really good stuff. And you'll notice where I have a 2 to 3K, it's up above everybody else, of course, because I wanted articulation. And that was really something in those days. And I've been doing all the sound stuff for right at 12, 13 years. I think I'm gonna get out of here. Just too much. As I showed you, some of the stuff was going on. We were doing very well financially, but I thought there was something else going on. So got rid of all my gear. I had a company buy the whole company, and I had empty buildings there, but that's okay. So what did I do? Of course I did. I came back to radio. I hadn't been there for 12 years. Never turned the radio on. And as you can see, a lot of that's pretty old stuff. But I get on the air and I was so disappointed. Oh my gosh. Like, what happened? Yeah, what happened to my great Art Collins audio? What'd you guys do? Because when I left, it was very pristine and clean and articulate, just because of the filters Art Collins put in the radios, 2.1 and 2.4, very narrow filters. And by using certain capacitors and resistors, they were able to get some articulation out of the audio from the Collins stuff. Well, what I started hearing on the air stunned me. I mean, I was going crazy. I said, what are you guys trying to do? It was all bassy. It was distorted. I said, we got to do something about this. And so what I did is I thought maybe I should borrow something from John Volkman. Remember him? Huh? Yeah, well, what I did is I come up with a little equalizer, little two-band equalizer. I didn't honestly realize that no one had done this because I hadn't been back on the air long. I figured surely somebody would have done it. No, they didn't. And so I had a group. We'd meet on 40 meters each night in 1960. It was 67 for many years. And I'd do all kinds of things. And one of them was designing this guy. And they would help me. I knew basically where we wanted these filters. You see, an equalizer, just a simple bass treble or any kind of, you can't change the frequency. The engineer sets the frequency. So I put the bass frequency at 160, and you, the operator, can increase or decrease it. What do you do with the highs? If you don't know, I really failed earlier here. 2.5K, max that son of a gun. I need articulation. And so you got to balance it. You really have to balance the bass and the treble. Anything with equalization, you have to do that. Well, that was quite something. I wrote an article about it and I sent it to QST, and they called me back and said, whoa, this is a revelation. We've discovered here at the ARRL, nobody's ever done equalization in ham radio. So this will become our cover story. You will get the cover award for July 1982, and it will be the lead open article. So I was very impressed and honored and quite blessed, actually. And so I did it as a DIY article. I wanted you guys and gals to build. I just, before I got me where I was and even today. And I needed to get people to help them build. So that was really a DIY article. I had all the parts. It had all the really nice layout and schematic. But I made a mistake. I put my phone number in there. And instead of a lot of guys building it, they wanted us to build it. They wanted instant gratification. So my plan had been closed several years. So I called two of my great solder gals back, and we opened a little corner of that 7,000 square foot building and started building EQ200s. It's how I started my career in building things for ham radio. And time went well. We were then really involved with the Southern California DX Club, who called me shortly after in '84, wanted me to build them a special headset because I had been building right after the equalizer. I realized that 2.45K was really important, and I needed to build a microphone like that because nobody else was. Now, this microphone was terrible sounding, but man, did it cut through the noise. There it is. Look at that graph. You see that I rolled off most everything under 500 hertz. But at 2.5, that son of a gun is 10 dB positive. A 10 dB spike. It's awful sounding. Well, why would you do that, Heil? They loved it, the DX Club. They were getting ready to go to Clipperton. It's a piece of history. And nobody ever had a headset. I didn't know that. And so, let's see if I got it here. Yeah, I should have gotten that. And I came up with what we called the BM10. They wanted a lightweight headset with our DX element in it. And so it was born. We're still building it, and we sell a lot of them. And we build it with other elements in it for ICOM or whatever. But I was very honored by that. But here's the deal. I want you to pay attention. This is very important. I have a great demonstration. Yes, it's a balloon. This is not a toy. This is serious stuff. I want you all to pay attention close because it's everything you're doing in amateur radio with audio. Let's take this balloon. If you have your transmitter bandwidth set, transmit bandwidth, that's the first thing you want to do is set the transmitter bandwidth. And we're going to set it to 2.9 on the top end. It's about as wide as all we'll do. But we're going to roll that bottom end off at 100 or 150 hertz. Fine. We also have an equalizer in all the radios today. You're going to bring that up. 2.5's got to have a rise. A little bit if you're doing, you got to tell yourself what you're doing. But check this out. For DX work, I want everything I can muster, all the power I can get. Where? 2.5K. And so what you do is you open the equalizer of 2.5 wide open, roll off all the low end. And then here's what happens. When we narrow it up and we've opened the door and the only way for RF to get out is through that 2.5, what happens? This is what happens. All of your RF is going to be peaked at 2.5K and you're going to be very articulate. Did I say it was going to be pretty? Nope. But I didn't care. When I go in a pile up, I know who's going to be on top. It's going to be all of us that understand this such important thing. It's a very important, and you never read about it. And it really, really gets to me. Well, I did something about it, of course, with the equalizer. In 1999, I get a letter from Dr. Inouye Communications, ICOM. He had a picture of his station. It had one of their great IC 781s. That was the first transmitter that had a scope in it. It was actually a CRT scope. And he had one of my equalizers. And for a microphone, he had one of my gold lines that you see behind me here. I'm going, wait a minute. He writes in this letter that he's getting ready to introduce a new line of radios for ICOM. And he wanted to be sure that when he did the equalizer, what frequencies were. Well, those guys are engineers. They know more than me, but it was kind of a social grace thing, just a thank you. And so from the Pro 1, Pro 2, Pro 3, all the way through the ICOM line, even up to the 705 that you see behind me, I'll come back to that, has my equalizer in it. And I was very, very honored and blessed. But I got kind of sad because a year or so after that, I'd hear guys on the air in the default mode because they didn't know how to set it. The instruction books were terrible. And so I had a job. We started doing things on our website to help people how to set their radios. I also started going to club meetings. I've gone to hundreds of them over my lifetime. And when COVID hit, I'm going, now what? Well, no, it's even better because I can do things with you now with all of this. I'm in my lab where I build and design things. I have a project right now. I normally don't talk about this much, but I got a biggie. Dr. Inouye sent me their little 705, which is an amazing transmitter. I was on the air today. You'd be amazed what you can do with 10 watts and the proper audio. I couldn't believe it. I mean, I've been having so much fun of it. But we needed an adapter. Nobody's going to build it. And they weren't going to build it for a headset. There it is. And it works really good. But that's not what it's going to look like. We also have one to plug your microphone into it. Here's what it looks like. I'm just doing a little mod and check to make sure that the production run's going to be good. But that's how it happens. This is my lab. This is where all the magic happens. The plant is about 6 miles up the road in Fairview Heights. But things are going well once we started getting together with ICOM. Here's how easy it is to set these things. Now, first of all, what is the very first thing that you do when you sit down at a radio, other than turn it on? You have to determine what you're going to do. You're going to do contest? Or you're going to do rag chew? Okay, let's do some rag chew. We have to set things so it's nice and sounds great, but still has good articulation. So we're going to set that, as you can notice there, the TBW, transmit bandwidth. 100 on the low end, 2900 on the top end. And that sets the bandwidth. We're going to go up to the base equalizer. I designed that at 160 hertz, and we're going to minus it a little bit, minus 2 or 3. The treble is at, you know where, 2.5K, and we're going to knock that sucker up to plus 3 or 4. And so we have a very nice sounding balanced audio. But what are you going to do if you're going to work DX? Simple. You set the bandwidth at 500 and 2500 on the top. And go up to the bass and notch everything you can. I don't want any bass. And we're going to notch all we can on the top. No, you saw from the little demonstration with the balloon, that's going to put all of your audio right where you want it. And it's so important that all of this happens. Very important. And all of the ICOMs are the same. The panels look different, but it's all the same information because it's the same equalizer. They also asked me to build a proper microphone because they don't build their own. Oh, it came in the box, Heil, it's gotta be good. No, it's not. And it really, really ticks me because people believe in things before they check out. Really, now come on. It's painted the same color, that's about it. And they're all, I know this because I work inside the plants. So I designed the ICM for ICOM. Almost spells ICOM. Won't work on Kenwood, won't work on Yaesu, nothing. Only ICOM. And it is a peach. Really, really nice. and does not cost very much money. That was important to me. I got in trouble. My wife owns the company, and I got in trouble because we're not making any money on it. I said, don't worry about it. I got enough to buy a Dr. Pepper bottle once in a while, so we're okay. At Dayton, 2 years later, Dr. Hasegawa from Yaesu comes in, and he wanted to do it better. And so we did a parametric equalizer for them. Parametric equalizer is kind of tough because there you are the engineer. You have to figure out everything. And there are 3 filters, and each filter has 3 things. You have 9 controls that you are the engineer, and you have to know where to set them. And that is why many people with Yaesus are still in the default mode, and that is sad. You go to our website, and it's very simple. Very quickly, you'll see where I set the first filter at 200, minus 3 or 4, going to notch it, and the bandwidth. How wide is that filter? 2 octaves. Don't argue with it. Just set it at 2 or 3. The second filter's at 900. There's a real boxy sound in that 600 to 900 region. You get rid of it, minus it down about minus 3 or 4. And of course, you know where the top end is, 2.5K, and away you go. All of this kind of stuff is on my website. You go to the support pages at heilsound.com, and you'll find a lot of pages, many pages for ICOM, Yaesu, Kenwood, Elcraft. So probably 50, 60 pages, and a lot of nice things that you'll learn. But time is running out. There's so much more about our microphones themselves. The one I'm speaking in is a PR22 that I was commissioned by Paul Rogers of Bad Company to build, and I built it for Joe. It's really incredible. It's got a really nice power focus on the front, but it has nothing at the back, and that's all done with phasing. And the PR40 is the magnificent microphone for that. And let me grab that. Well, let's see. We're not going to have time to get into it. Let me come back sometime and let's cover just the microphones. Sirius Radio just bought 250 of them, tossed out all their RE20s. And so many people are using our microphones, the recording studios, that's the PR40. Broadcaster, yeah, Mickey Mouse, so on. But anyway, we need to come back and help you with some of that. And of course, the expeditions, we've been the top choice of operators for 35 years. But we're going to get in a little bit of phasing. This is so important. It's my favorite subject because there's so many things that phasing has to do with your signal. How does the Yagi work? There's no batteries. When Dr. Yagi started building the Yagi, all he had was a field strength meter out in front and a dipole, a resonant driven element, resonant. So he didn't have tuners, any of that. And he started moving, had all kinds of aluminum on that boom, quarter wave, half wave, all that. They were in multiple wavelengths. Found out that at one spot he could get gain. Wow, got gain and no batteries. If he put it behind longer in the right space, it was out of phase. And so he could get rejection. Well, how does that happen? It happens with phasing. Phasing is something that affects everything we do. I have a great demo. Let me check this.
Hey, Bob.
Yeah.
Hey, sorry to interrupt here. We're done with our business meeting, actually. We got it done before you. So if you want to go till about 8:20 our time, I guess 7:20 for you, we do have a little extra time from what I originally told you.
Okay. Very good. Very good. Thank you. Okay, these two microphones, PR22s, that I was commissioned by Paul Rogers of Bad Company to build because no equalization is necessary. You notice I didn't touch anything. It's very articulate. Okay, they are both the same. I know they're different colors. And if I bring them together, they're in phase. We're going to increase our level by 3 dB. Now that's something else you need to pay attention to. Doubling your power only gets you 3 dB. Here we go. 1, 2, 3. What? Talked about listening. Close your eyes. I'm going to take away 3 dB. Here we go. 1, 2, 3. The human being cannot detect 3 dB. So now what are you going to do, huh? You have to think about these things. You're running 500 watts. You don't have the right microphone. You don't have equalization. You don't believe in it. And so you're just going to go out and buy a kilowatt. By golly, I'll beat those guys up with my bassy audio. Sure, I will. Will you? You just heard what doubling your power gets you. 3 dB. The human being cannot detect 3 dB. I can get you 10 with the right microphone and equalization. Think about it. Anyway, this microphone, I just put a plug in here. That plug is backwards. Pin 2 is the 3 and 3 is the 2. It's out of phase. When I speak into it, the diaphragm comes up. This one in phase, it goes down. Well, wait a minute, Heil. There's no difference in the sound. That's right. Watch the screen. Watch the screen. Listen what happens when you have two sources out of phase. Nothing. Nothing. They cancel. Nothing. The bomb could go off and you're not going to hear it. They cancel. And it affects everything in ham radio. Some idiot piles up on your nice contact one day and you hit your notch filter and he goes away. How'd that happen? Let me change mics. Well, it happened very simple. When you push that button called the notch filter, it takes his signal out of phase from you and he's gone. So many things rely upon there. And I need to come back and get into my phased array. This is a great thing. This phased array is wonderful. And I get about, on 75 meters, I'm getting around 20 dB tops. Usually it's around 10 to 12 dB gain or rejection. Think about this. This is on 75 meters. And I just love it. I mean, I can do things with it you never thought about doing before. And I put up a pair of telephone poles that I got from the telephone exchange building, and they gave those to me. They were 90 footers that had rotted off, and so they cut them off and they gave them to me. And you can do the same. A lot of power company, they got things laying around they like to get rid of. But anyway, it's just wonderful to be able to do that. But here's how it works. Now pay attention. Yeah, on 75 meters, you need 126 foot at 0.66 velocity factor. A lot of people do not realize the velocity factor. How fast does the electrons go through that piece of coax? That's very important, and a lot of people don't pay attention to that. On RG213, 126 foot, but both of them had to be the same height, and I wanted them 64 foot apart. So they're absolutely all done so that it's monumental. And then you couple them together through T's, but look at the connection. It's 43 foot long on 75 meters. It's a delay line. So the remote relay, because this is 500 foot from the shack, when you take it to the left, that's your driven element. All of your power goes there. And the delay line, that delays it. So it's out of phase. And you know what that does. You reverse it the other way and go to the other coast. You can do that with verticals. You can do it with all kinds of things. And you don't have to have a remote relay. You can, if the lead links are long enough to get to a switch box, and you can come into the station and do it with just a regular switch. One of my good friends, K9EID, who his name is Dave Heil, but he's no relation. We have a lot of fun with that. He took a 20-foot piece of 2x4 and put it up on his tower, and he had varnished it and all that kind of stuff. And for 20 meters, and boy, that thing works like a bomb. And so there you go. And you also want to talk about this. If you don't take anything away tonight, boy, I sure hope you took away the 2.5K. Let's talk about the height. There is an optimum height of your antenna. When I first got on the air in 76, I went out and got a extra class license so I could get on 40 meters and 75 and all that. Because I was a technician for 17 years and I remember that. Well, every night we had a group on 40 meters. There were about 6 of us: California, New Orleans, Cedar Rapids, Iowa, Florida, Ohio. I had a reference antenna. We did this 1 month. Every night in this month, I had a different antenna configuration. We had a reference. See, that's the whole deal. I'll hear guys every once in a while, "Hey, Bill, how's my new antenna sound?" What do you mean? Against what? Because atmosphere changes, as we all know. So I had a reference antenna, and I would start out on that. And then we'd go to these different antennas each night. First night it came out with a dipole. That'll be 40 meter dipole. I'm sorry, there is no better antenna. A lot of people argue all this all you want, but I'm telling you, of all the different experiments we did, this is it. Resonant dipole, so you don't have to have a stupid tuner. And you can do fan dipoles if you want to do multiple frequencies, just so they're all resonant, so on. It works great. Okay, here we go. First night I had it at 20 feet. And we're referencing this against the dipole. Everybody took. Next night, we'll go to 30 feet. Let's go to 40. Wait a minute, this signal got weaker. What? I went higher. Well, let's go to 50. Didn't really change any. What? So I came back to quarter wave. The minute that we did 33 foot, whoa, wait a minute, that's better. The next night I went to 66 foot, and oh my goodness, it's all about what happens to the second wave. What are you talking about? Pay attention to this. This is very, very important because there is an optimum height for your antenna. There was a publication that Art Collins wrote, and it states most transmitting antennas of resonant dimensions elevated at a quarter wave above ground are as close to 100% efficiency as possible. You want to go back and read that again. It's not the higher that you get it. It is not the higher. No. It's the fact that it has all kinds of things that happen when they're resonant and they're quarter, half wave, whatever. Because here's the way that looks and works. You have a direct ray from your antenna, but there's also a reflected ray. Man, it doesn't have LEDs in it, so you can't see it, but believe me, it's there. And by raising that antenna on your specific frequencies, quarter waves, half waves, you think you turned on an amplifier because now you have 2 signals. The transmitted signal is the result of those 2 rays. Why do we not hear about this happening? It's why I'm here tonight. It's why I take a huge portion of my life, almost every night, to bring some of this incredible information. Because I'm not reading it, and I don't know why. And a lot of other things, simple things. Never, ever in your life use pulleys. No. Why, Heil? Why didn't I do that? Because they're going to freeze up. I don't care where you are, you're going to have all kinds of problems, and especially in the winter, rain and stuff, and it doesn't work. So I use carabiners. What is better than a carabiner? It works so good. And you want the one that you can lock. See it in the right lower left of the picture. The little red thing locks it. What do you do for center insulators? I make my own. Take a piece of fiberglass and drill some holes. Or I've done it using some plexiglass. That all works great. And we talked about the fan dipoles. My favorite dipole is the MIT. No, not the bazooka. I hate the word, and I hate the fact that it's not proper. MIT designed this in 1938 for the government. They commissioned them to design a broadband antenna for radar on 80 meters. And it is broadband. I mean, no tuner necessary, thank you. And that's all I use most of the time, if possible. It's really great. You want to go study this. Don't study the bazooka thing. You look up MIT coaxial, and that's what you want. And it really plays. You can use at the ends, they're shorted there where the twin lead joins the RG58U with 0.66 velocity factor. That's very important. And you don't want to use 213, it's too heavy. You use 58U. You solder those all together, the shield in the center and the two leads from the twin lead. And the length of the twin lead, or you can keep going with RG58, that broadens the antenna a little bit. And so I've used them with just pieces of wire out there, and there's the dimensions of all of that, which is in my handbook. We'll talk about that in a while. But there's all kinds of things you can do with antennas, and it really works. If you have a tower at all, you can do a really nice 2-band, sometimes 3-band, using traps, and use the tower as the ground. You attach the shield with hose clamps and stuff to the tower, and then the tower is really well grounded. There's just all kinds of little things that you can do with antennas. And again, I don't ever read it. And this one works really good, and it's directional also. And I did a dipole here recently. I'm at a different location here, and I only have like a 80, 90 foot lot. What are you gonna do for 125 foot? Well, I have a neighbor across the street that moved in there recently. Her husband, who's now deceased, darn it, terrible. He was a ham. So she's, kind of pleasant about hams. I said, hey, can I borrow your tree? And she said, what are you going to do? I said, I want to put an antenna wire in it. I have a neighbor behind here that's got a 70-foot tree. I put all kinds of things in his tree and mine. But that one would give me 125 foot, so that's what I did. It goes across his house, my house, and across the street, her house, but it's all 70 foot. Here, check this out. I use wire from MFJ. If you're looking for antenna wire, this is your baby. It's really great. It's 7 strands of very strong copper and steel. It's wonderful. And I put that all together, 125 foot long, using their wire. And I had a friend that's got a really neat potato gun, and we shot that thing up. That thing will shoot over 100 foot easy. So we launched it over a tree, and my tree, or my neighbor's tree, fine. But you cannot see it. I was out there again yesterday. My sister came by to visit me. She's heard me talk about it. I said, can you see the antenna? You got to really catch the sun just right. So these are things you can do when you really need help. And for those of you that like open wire feeders, nonsense. That stuff is so much trouble. You can't get it into the house properly. Any kind of snow or rain on it, it changes. Uh-uh. Here's what you do, and this really works. Use a pair of anything, RG58, RG213, RG8, whatever. Same length now. It doesn't make any difference what length they are. But out at the antenna, you short the shields together, solder them together. And the center conductor drives one side of the dipole, the other side of the dipole. Down in this shack, solder those shields together. They do not touch the center conductor. The center conductors go onto your balun or tuner. With something that's 120, 30 feet long, you can work every frequency there is. It really works great. And then you don't have to worry about how to get it into your house. This was a thing, as you might think it's a cartoon, but it's not. Got this from an Army book. It's in the book of communications that if you're in the field and you have no antenna, a way to launch an antenna, drive a nail in the tree. We tried this on that experiment, everybody, and I'm here to tell you the truth. It works. Didn't get very big range, but we got 40 miles on 40 meters with it. Honest, 100 watts. It was really cool. So you see, there's a lot of things. I had a friend of mine in Kansas City that came to me and he wanted to show me this. He wanted a resonant dipole in his attic, but he wanted a fan dipole. So he comes up with the idea of doing 80 meters through 2 meters. And he did it. And this is how he did it. Behind each one of the 80, 40, those were wing nets, as you can see there in the lower left. And he put a piece of aluminum all the way down. And so they all connected to the same side, same on the other side. And so then this is what it looks like. Isn't this cool? And there are all the leads in his attic. Here's another view of it, a little easier to see maybe. And so for all the doom and gloomers that this won't work, he's worked 100 countries with 100 watts. Check it out. Here's his 40 meter. It's almost flat, the whole bandwidth of 40. But he wanted the 6 meter one, and that one's really sharp. He knew it was going to be sharp, but he only wanted it on the repeater frequency that he listens to. So these are the things you can do. There's a lot of just fun things. If we had more time, I'd get into some of this. You ever tried a slinky? Believe me, it works. It's wonderful. I've loaded fences. I've loaded hustler antennas from your mobile out on a deck. It's all work. Do not spend your time worrying about SWR. I was in this hobby for 20 years and never knew what it was about. Too many people spend too much time. Put it up and try it. You'll be surprised. If you're just so particular about your SWR, do this. Put your dummy load on top of your tower. It is perfectly flat. Of course it is. But there's just so much about antennas. Last, I got to show you this. When I got into this hobby, remember, it was a KMOX CBS engineer. I had been in it 2 weeks. He started helping me. And he taught me how to solder coax connectors. Because he said, you look in the handbook, you got to go through those little holes. You cannot guarantee me that all of those pieces of shield are soldered. Nobody can. And if you do a lot of heat on them, you're going to melt the inside. So here's how you do it. And it really works great. So easy to do. And I never showed many people because people started making fun of me. Because I did all of them that way. The little RG58 adapters. The secret to that is you put that in a vise and you solder that really good, really hot, so you can't touch it for about half an hour. So it's already tinned, so to speak. And then you put your coax into there and it solders really nicely. and you better tape it up because people are going to make fun of you. Well, here's the deal. I suffered my whole life not telling very many people about that. I had it all taped up, didn't talk about it because I knew what was going to cause a riot until about, oh, I don't know, 6 or 8 years ago, I visited K3LR, the multi-million-dollar contest station. He's a part of DX Engineering. I visited the station. It's unbelievable. Go look at some of the stuff on YouTube for K3LR. Unbelievable. And over in the corner, all these coaxes. I don't know. There must have been 70 or 80 of them coming in from all of the antennas. But they were all soldered like that. I said, Tim, you're my hero. And what are you talking about? And I told him his story. I said, I haven't told anybody about this. I'm embarrassed. Don't be embarrassed. He said, they cannot guarantee those are going to be every little thread of that shield is going to be soldered. Don't be worried. You're the smart guy, not them. And so, okay, there you are. Trust me, it is. And how do you bring it into the house? Before this tile was laid, we put a toilet flange down. And then after the tile, that's what we did to it. And it's really cool. It works great. So that helps you with a lot of that kind of stuff. And we should come back some night and talk about building if any of you kept up with Ham Nation the last 2 years I was on, we had over 1,000 people build a 5-watt AM transmitter. Every Wednesday, we'd give you 5 or 10 minutes, built the power supply, the equalizer, all that. It was really cool. Really cool. And had so many people build all kinds. One guy put it in a cigar box. Another guy put it in a chassis for an old amplifier. Guy put it in his kid's lunchbox, on and on and on. But the whole deal there is we had to respect high voltage, as we did. But I have one more thing I want to bring to you before I leave. I, for years, working for the companies, I understand I'm inside these plants and I'm pretty vocal with them on some of this stuff. It's like, you need to do something about your audio, your receive audio. I'll receive audio fine. They're only talking about their filters. They're not talking about the actual audio. Every transceiver made, I don't care if it's $10,000 or if it's $400. Every one of them have 10% distortion, usually a couple, 1 or 2 watts. They're just awful. So I did something about it. I borrowed a page from what I learned, page or 2 or 3 really, from Paul Klipsch. And we built this really great speaker. It's a 5-inch speaker. And the speaker it's an enormous sounding speaker. I'm so proud of it. First of all, look at the magnets on that thing. And we tuned the box, the cavity, to that speaker. Take it out into free air, and then you know what's going on there. And it's 25 watts at 0.1%. This is hi-fi level. Balanced line in. But what do we do about the rest of it? Well, the rest of it is the equalizer itself. This is an amazing piece of gear, and I'm very proud of it. First of all, I took a lot of notes from you guys over the years. The headphone amplifiers they're all separate. I mean, most things are just wired together. No, they're separate line amps, very low distortion. You can have an operator and a logger, or, and this is really where the big move is coming, you can have the left side of your headphone and the right side. So if you have a hearing imbalance, you can fix it. So many of these are being sold for televisions, computers, all kinds of things I never thought about. But we have 3 filters, one at 6K plus or minus, one at 160 hertz plus or minus, but the center is a parametric. That means you can change the parameters of that. So we're going to set the gain of that filter, leave it, and this will rotate from 400 to 4,000. And the minute you hear this recording, this now understand, this is off the air. There's the way you hear him. You can't change him. Bingo. Back to normal flat. This is the way you hear him. 2.5K. More time. This is the way you hear him. There's just no question. There is no question about how incredible this little box is. And again, nothing has ever been done like it. Oh, there's some little toys out there, but this is a serious piece of gear. And I'm very happy with it because it's helped so many, especially those that are hard of hearing. And that really has been something for me to bring to the market of, we have so many other things. You really want to catch my handbook. I didn't write it, I compiled it. A lot of notes from the CBS engineer, from Paul Klipsch, Wes Shum, all of these greats that I learned it from. You don't read their stuff. Well, there it is. Most of the dealers have it, but if you order it on our website, heilsound.com, I'll sign it for you. Oh, golly. You also can go to the website, and this is on there, and just download that. It all starts at the microphone. Last but not least, I was about 8 years ago, we were invited to display in the Rock and Roll Hall of Fame. We're the only manufacturer there. These are a lot of the gear we used. And a couple years ago, I received a PhD in music and technology from Mizzou. So it's all something that without ham radio, I don't know where I'd be today. Yeah, I do. I'd be playing the organ at the theater. That'd be it. But I'm so happy to be here tonight. I'm sure you're going to have a lot of questions at some time. Let's come back and we'll focus on just some of those. That's what I'm doing now. I'm doing some of these 4 times, and we really get a lot. So, Aaron, thank you so much for having me. You have any questions?
Hey, Bob, I'm actually hosting this from home because I was sick yesterday and I couldn't go to the library. I believe they're working on tearing down at the library currently. Since I'm hosting from home, if you have time to stick around for some questions, we can keep this going for however long the people on Zoom need. I guess I really don't have many questions myself. I'll say I did buy a new Yaesu rig a while ago, and as Bob said, I had all my transmit audio just on the defaults, and nobody ever really said anything. Once I watched one of Bob's presentations, I started setting the equalizer the way he said, and it made a huge difference. I ended up taking a little bit more low end out for my voice, but once I made those changes, I get so many people just out of nowhere complimenting on my audio. So it does make a very, very big difference for people hearing you.
Yes. See, the whole thing about what we're talking about tonight, don't misunderstand, is not Bob Heil. I'm just the messenger. Everything I talk about comes from people that have taught me. It's all the science of it. And that's where it really helps, is that we're going back into many years. Well, I'm glad that helped you. Does anybody have any questions?
This is Mike, NHCEY. Can you hear me?
I do.
Hi, Karen. I just got 2 Yaesu 991 and 3000, and I played with settings of the equalizers or what have you. But what you're saying, I gotta go back and see if I did it right or not. But it doesn't make a really nice difference. And I really enjoy your mics too. I've got 2 or 3, the gold mic and the platinum.
Yeah.
I do get a lot of comments too, but
yeah. Well, I can only tell you that when you turn the equalizer on or off, if there isn't a monumental difference, I mean, one of these go back and look at my pages. Need to
Yep.
adjust. Yeah.
I wish I had good neighbors with tall trees.
Yeah. Isn't that cool? Yeah.
And
She had compassion for me because her husband was a ham.
Columbus, ham friend of mine, had a neighbor across the street that could let him use his chimney. So we put a dipole net up for him on that. Worked
Yeah.
fine until they sold the house and the other people weren't
Oops.
happy about it.
That issue came up yesterday when my sister was here. It said, "Hey, if she sells that house, you don't have to say anything about it. Nobody can see it anyway." She's not going to sell it for a long time. I'm good. Okay, well, thank you. Stay in touch with me as to anybody. I'm always here for you. K9EID at ARRL. You send me an email. That's what I do all day, other than over here building stuff. I answer a lot of emails. No questions dumb the first time. Be glad to help you. Anybody else?
Bob, Stefan, NAWB. I just want to say thank you so much for the presentation tonight. Thank you so much.
Okay, well, thank you. Yeah, Stephen, it's good to see you. I knew you would be in here somewhere. But you can see where all my time's been spent the last 2 years and beyond. It kind of changed the direction of what I had in mind, but that's okay. This is much more important, let me tell you. So we'll get on with the project one of these days. But thanks for all you do to help us. Anybody else have something going on? No?
Just want to add my thanks. They're very informative.
Well, thank you. Thank you. Well, if you have a couple of minutes, I end all of these that I've done, and now it's hundreds. I give you the choice. I can walk about 10 feet in front of me and fire up my theater organ, or I can walk out the door and you shut down Zoom. So you tell me what to do. If you want to go on and so on, why close the Zoom, that'd be fine. Or I can, on the way out, I can stop and play a little tune for about 2 minutes. How's that? You tell me what to do.
Bob's a phenomenal organist, by the way.
The organ sounds great to me.
Yeah, I'll keep stuff going here for as long as people want. And if I will add too that for anybody that's trying to set their equalizer, something really, really handy is there's several cams that will live stream on YouTube when they're working the HF bands. It's really helpful to talk to one of those guys so you can hear yourself as you're making adjustments.
Sure.
The one that comes to the top of my head is W7HU, Whiskey 7 Hotel uniform. He live streams almost every day.
Yeah.
On the band, so
yeah,
that helped me with. I started with Bob, and I ended up taking out just a little bit more at 200 hertz, I think, and that's what worked for me.
There you go. Okay, well, this has been great fun for me. I hope I get to come back sometime and we'll see what's happening in your world with all of that. Let me turn up a couple of buttons here and turn off a couple of buttons, and we'll go fire up the big Wurlitzer for you. So thanks for having me. Look forward to catching you either on the band or back here sometime soon, okay? Thanks, Aaron.
Yep. Thanks for doing this for us, Bob, and everybody at the library. Wanted to make sure to tell you thank you as well.
Okay. Got one more switch to throw here. That's got that, and that's got that. Okay, we should be good. All right.
Fantastic, fantastic.